In just a few minutes here, we're going to show you how to use the power of streams. Streams allows you to use complex features like filters, sorting, distincts, counts, and even map functions from within your application with only a few lines of code. Let's see how this works. So let's dive into some stream examples and go over how you can change your programming domain by doing functional programming using streams as opposed to empirical programming. So we can have a simple array. Let's create a string and let's say names equals curly brackets Tom, Bob, and Fred. And this is just an array. It's not a list. And we can create a list from that very quickly by defining a list. Let's call this namesList. And this will be an array of, and I'll just say names, array as list. Now we have a array list here of names. We can actually go through and print out information about this. For example, we can get the size. Let's call this the array size. And that's from our names length. We can also print out the list size. And that is not length, that is size. Okay, so we can see how we can quickly bring an array into a list. Well, this is all about streams, so we don't really need anything else other than a list. We're going to create a quick stream here of these names just to show you how to print them out. And we can very quickly simply say namesList.stream, and let's do a for each. And for this, I will do a system.out : print line. And let's run this. We should see the size of the array, the size of the list, and we'll print out the values within the list. So we have the array size is 3. Let me change this to print line and run this again. We see the array size is 3, the name list size is 3, and the values are Tom, Bob, and Fred. Now we can also change this for loop here and use a lambda, and we can add this in here. Let's call it name. And then we can print out the value of name. So this will have the exact same effect. Okay. So you'll find most of the time, whenever you want to use something like for each, and just print out the value that's passed in, that they just use the : to optimize this to make it more readable. Okay, so now we can actually see the value. So what is the power of streams? Well, we can actually go through and use some of the stream features. For example, in namesList, we can find the link to the string. But we can do that with the count function. We have two types of methods within stream. They're intermediate and terminal. The end in here, we typically have a terminal count, and nothing else can happen after that. So let's go through and let's print out our count right here. System.out.println, and we'll go through here and say size equals, and as we expect, we get a value of 3. But we can actually go through here and do a little bit of filtering on this through an intermediate, and I can say filter dot. And what we can do in the filter is we'll have name, and we can have this a Boolean expression. We can say for name equals, I'll say Tom. So how many of these names equal Tom? Let's save this and run it. Now we can see the value is 1. So what we've done is we filtered this. I could go through here and say not equal Tom as well. And this will pick up the other 2 names now. Now we can very quickly filter these content as well, rather than just doing a simple count. And I can say list.stream filteredNames. We don't need count anymore, but we can still use filter. But now we have to use something, a different type of terminal operator. And in here, we'll use collect. And it auto-completed on the Collector.toList. And this is going to go through and generate a list for us. So if we go through here now, I can add another for statement. And in this for statement, I can add in filtered names. So let's see what names are filtered. So we have a couple lines in there, duplicate data. So let's put a system.out.println. We'll just put a line break in here. There we go. So we can see where we start again. So we have Bob and Fred. All right. So what if we add some more values in here? Let's say we add in Joe, Bob, because he's another friend, and Sam. And we'll add Joe, because he's another friend. So let's run this again. Now we can see that we have Bob in here multiple times, Joe in here multiple times. But maybe we just want to know how many friends that we have. We can very quickly go through and generate a unique list. So again, we'll go through and use our unique names, and we'll take out the filter. We're going to make this distinct. And this distinct uses the equals operator. So let's go through and print out our unique names. Now we only have Tom, Bob, Fred, Joe, and Sam. These do not seem to be sorted. So we can actually take our list here and we can sort these. So let's go through and let's sort this. And we can use the sorted terminal method. And this will sort before it creates the distincts. Now we have it sorted. Notice we can also take the sorted, and I can move that to after distinct. And this sorted uses the equals processing. So I can do it before or after. Notice that before I could find the length very quickly simply by looking at my list.size. But now I can look at other information about this. So if I want to know not just how many items are in here, I can determine the length of them as well without having to actually retrieve them. So we can go through and track not just our creating a list of the unique names, but I can find out how many unique names there are. So I'll say long unique name count. And we can go through and take the stream, determine it's distinct. We don't care about sorting it anymore. But we do have a terminal method we can use called count. And notice it recommends it because we already mapped this into a long. And then we can go through, put a couple print statements in here, and say our count now we know our count is 5. Now what we've done here is we've actually taken a list and we're creating a distinct and counting it. But we could add different filters and everything in here. In the old days, you would create for loops and have temporary variables, maybe add it into another temporary list, and that was fine. But with the functional programming of streams, it optimizes all of this and it cleans up the code significantly. In the old days, we would have a list, and let's go with namesList, for example. And let's take the actual name list right now and let's print that out. So we'll do system.out print line. Let's print a blank line before that. And we're going to say raw names list. Let's print this out real quick. Okay. Other things that people used to do in the old days, whenever you had an array of names, is you would sort in place. You could actually say arrays.sort and pass in names. That would then sort it in place. So if we go down and run this again, we see this right here is not sorted, but now that we actually have sorted it in place, we'll see that it is in fact sorted. So this is kind of how in the old days we would do it. We don't work on this anymore. Those days are gone. The days of having for loops and while loops and temporary variables are gone. And now we have these streams, which is significantly more optimized. So we went over creating a stream, creating a distinct, sorting, and creating a collection, a collector.toList. So most of the time you're going through and you're doing some level of filtering. We have two major components that we use. One is a filter, the other is map. So let's take another view and let's go through and create a couple classes. I'm going to say user. In this user, I'm going to have a string for ID. I'm going to have a string for name. I will make these private. I'll generate getters and setters. And I'll also create a constructor . So I can very quickly go through here and create some users. Specifically, I want to create a list of users. So I'm going to say list user I'm just going to say user list. And this is going to be an array as list. And I'll create a new user. And I need to put in an ID. So this is a string ID, 1, 2, 3. And then a name, Fred. I can then put in a new user. And the ID will be 222 Tom. And this doesn't want this running in a static class. So we'll go up here real quick and we'll change this main real quick. And we're just going to call this any class public void run it. And then in my main, I'm going to say main, new main, then I'll say m.run it. There we go. That'll take care of this error right here. So now we've created two users in this user list. I can now go through and create a filter list. So if I want to have a list users, filtered users, can I quickly use .stream .filter, and I could actually go through here and say user.get, I'll say name equals to Tom. And I'll use the default collector. And so the filtered users will very quickly get filtered out for only Tom. Now, when we print this out, this is different. This doesn't work the same way. We're saying a Java object reference. So here, we need to use the lambda where we pass in system.out.println, and we need to pass in user.getName. Now when we run this, we can see the actual name. There we go, Tom. So other things that we can do with the collection, we went over the filter. There's also a map. So let's add a new class here, and let's call this class here from user. We will create a user DTO. And this user DTO isn't going to have an ID. I'm not sure why, but it won't. So we'll take out the getters and setters for the ID. Now, if we wanted to filter one class to another type of class, we can use streams to do that too. We'll say list user DTO, user DTO list equals user list dot stream dot map. What will this do? Well, map is a little bit more powerful than just filter. Filter simply says, yes, based on a Boolean expression, whether it's added into the result or not. Map can actually return another object. So we're going to say user, and this can be a more complex object. Specifically in here, I'm going to create a user DTO. So I'm going to say user DTO equals new user DTO. And when we created user DTO, it only has name now. So I'll use user.getName. Let's go ahead and bring this to the next line so it's more obvious what we're doing here. So user DTO, from this, we've created this. Now we're going to return the user DTO. Let's fix typo here. So now we're returning it in here, but we don't have a terminal method. So I can say collector or collect this, and this now returns that. So we can very quickly see what we have in here. And this right here, I can go through and we can say user.toList now looks like this. And it has the same items, but now they're user DTOs. So map is very powerful. It allows us to map in there. As with any Lambda, you can use one line to return something, or you can put it in a curly brackets, but then you need a return statement. So there's a lot of capabilities in here. We have distinct. We have all sorts of other capabilities with the map and filter, but we haven't gone over some basic math. And there is some capabilities to do some basic summing in there as well. It gets a little more complicated, but let's add a list of integers, int list, and this is going to be an arrays of list, and we're going to give it some integers, 1, 10, 20, it's as list, 100, 10, 5. Okay, so this is now our array. Let's say we want to go through and add all these numbers up, sort them, etc. I can very quickly go through here and say int list.stream .sorted .collector. This will actually go through and generate a sorted list. So these values are now sorted. We can print these out very quickly to verify that they're in fact sorted. So we should have 1, then 5 in our list. So 1, 5, etc. Other things we can do is we can determine the value of these by summing these together. We can convert these to a long, map to long, and in here I'm just going to say I to I. We don't need to do anything else. Get a greater than here. So we now have summed these integers together, and I can go in here and say sum, and now I can go through here and do a system.out.println. I can say sum equals sum. And let's run this, and we'll quickly see that the numbers we just had have now been added together. So not only can we sort them, we can get the sum. But the power of this comes in when I want to do something such as return the values with something filtered out. So I can say filter, and in this filter here, I can say I less than 25. And now if we run this, the values are smaller because we filtered out the value of 100. So these are a lot of powers we have. There's also other capabilities that we have in here. We can very quickly find the min and max values. We can find uniqueness in here. So I have this list right here where I have these numbers, and I can actually go through and I can change this output right here where we have these int values. We have 20 and 20 in here twice. We can go through and we can change this very quickly. And instead of having a toList, we can use a toSet for the collector. And if we use a toSet for the collector, we'll take sorted out. We need to change this list to a set. And now we'll run this. We should see the second 20 value gone because it's now a set. So these are some of the things you can do with streams. They're very powerful. Streams in combination with lambdas are a very, very powerful combination. I hope this helped you unlock the power of streams and take your Java programming to the next level. Please like and subscribe. I hope you enjoyed this video.